Our next presenter is presenting on equipment corrosion, prevention, mitigation, and assessment reporting. Henry Canipe is a management consultant, practice leader for the Kercher group.
This presentation really is based on a presentation that was provided at a corrosion conference in April there out in California. It struck me that the corrosion is a topic that we certainly cover periodically in this venue. I actually saw a really nice presentation from Jim Chupas a few years ago at this same conference, and I saw another one from either further back with Jim Smith. So this is obviously a long-term issue for you folks, and certainly it's not going away, that's for sure. But the core of this presentation is going to be talking about a 2015 project done with Jeff there at UDOT, and that was really my first big exposure to a fleet where corrosion was a major problem. You can probably tell from my accent that we don't have a lot of snow down in North Carolina to fight about, but when you do a lot of work with the DOTs around the country, this is certainly a part of their key mission. We'll include a couple of observations from projects done in the last couple of years at Illinois and at Missouri, as well as there's a slide or so from the Washima scan tour, which if you haven't read that scan tour, I'd encourage you to read that document. There was a lot of good information about both corrosion as well as a lot of fleet management practices. And maybe that's the challenge for you folks, is that there's so much information out there and so little time, and it is really hard to just try to understand what information exists. And finally, if time allows, I would like to highlight some work that Jeff and the UDOT folks did as a result of that work in 2015. I think it's a real tip of the hat to those guys, and it's certainly been a success story that I would like to make more folks aware of. So, moving on, the 2015 project looked at UDOT's Class 8 fleet, and it was looking at 3 areas, and in the interest of time I am going to just touch on a few areas with the idea that those of you who have more interest in some of the details will eventually download the presentation, and there's even some notes with hyperlinks to some of the research and project work, so I'll recognize the fact you folks are capable people and not try to read off the slides. I was actually coached about that a little earlier today by one of the members of the audience, so we'll see if we can't learn from that. So just to jump to the end of the story, we did recommend reducing UDOT's replacement criteria quite a bit and implementing a corrosion assessment program, which is the last few slides on this presentation. And we also recommended today prioritize replacing those units that had some real corrosion damage, which is just a sort of a good common sense thing. The outcome was that UDOT adopted the replacement standards that were recommended. They also did implement a corrosion assessment program. And I think the success story in a nutshell is that they were able to significantly increase their fleet funding because of the results of this work. So, in a long way, after everything's said and done, the success of a fleet manager, especially for you guys, is to a large extent really how successful are you able to get the funding you need. I mean, that's a really good yardstick for how successful you're being, and that's the fleets that are able to do that really have something to talk about. I guess just as background, we're going to focus on the corrosion part of the fleet, the UDOT project at this point. They were having a real experience with corrosion-related frame cracking. It was related mostly a function. This was part of the findings, but the nested frame design, the nested seat channel. I see a lot of head nodding. I know this is a common design for a lot of vehicles. They had 197 vehicles in their 500 vehicle Class 8 snowplow fleet that had this design, and 50 of them had already experienced frame cracking at that time. They also were experiencing a lot of issues that I've heard other folks talk about: oil pans, differential covers, so on and so forth. Just a variety of issues related to really use of the winter maintenance chemicals and so on. And so this project sort of touched on all those areas, trying to figure out what it is that UDOT could try to do differently, and of course by proxy you folks may be able to draw some lessons from. This is just a slide that you can, if you can orient yourself a little bit, that's the frame rail on a Class 8 UDOT truck there. You can see there in the top, I do not have a laser, well, I guess I do, but anyway, hopefully you can see that there's a crack right along the top of that frame rail. And, you know, at this point, this truck really is unusable. UDOT, I won't get into the details. There is a report available if you care to dig into it, but UDOT tried a variety of things. We basically helped them cost them out, and there was no scenario that it made sense to try to repair these trucks. They were really just in a position of sidelining them, getting rid of them. Here's another view from an end view of a frame rail, and you can just see all the scale and all the rust and just the problems they were having. And I'm sure this is not unique to UDOT. In fact, some of the other DOT fleets, I've seen variations of this problem, but it's frankly not quite as bad as at UDOT. This is a really particular issue for these folks. As part of this project, we did a review of literature. There is a fair bit of literature out there, and I guess I want to tip my hat to Greg and the people at WashDOT. Frankly, some of the best research on the area of corrosion and corrosion prevention was originally sponsored by WashDOT, and then MnDOT did an update of that work through the Clear Roads program, and there was some pretty good basic research about the sources of corrosion and what you can do to prevent corrosion and treat corrosion. And it really formed the lion's share of the most relevant research that we relied on to try to help UDOT figure out what they wanted to do about these things. And obviously that hopefully we could help them recommend some changes in specs and in some of their equipment storage and cleaning practices, and that was in fact the sort of the outcome of the study. Besides the literature review, we did do a survey of a number of peer states, especially in the Rocky Mountain region, and we were very pleased to get 14 responses. A lot of the folks that responded are in this room: Caltrans, Oregon, Washington, Idaho, so Wyoming. And we learned a lot of information from that. And there was obviously clearly a problem there as well as other places around the country. I'm currently working in Pennsylvania, and I can assure you they're no stranger to corrosion either. I've already touched on this about some of the research. I will say the major findings that we had from both the survey and the research was that these corrosion issues have always been out there, but they've certainly gotten a lot worse as the industry has moved to a lot of the wet type chemicals, and especially the hotter chemicals. And in conjunction with that is the fact that the driving public increasingly expects to drive on dry pavement or on clear pavement. And so there's a change in rising customer expectations, a change in maintenance practices. And you know, when you're dealing with long-lived equipment like your big trucks and so on and so forth, it really takes a number of years for these things to start showing up. So the change in these practices 10, 12 years ago, however many years ago, it's just really been in the last few years it's hit this fleets hard. And so that's the reason this is becoming it is and is becoming an ever more increasing problem, and that's what we're a big theme from this presentation. Like I say, we had a number of DOTs respond. Most of them indicated that they had moved from abrasives to more liquid type chemicals over the last few years, and of the reasons that I mentioned. They also indicated that one of the reasons they went away from abrasives was just simply the amount of work that had to happen post-event to clean the roadways up. You had to sweep up the sand or blow the cinders or whatever the dickens you were doing in your state. But we did notice that was clearly a trend, and I don't see any sliding of that trend. That's probably going to increase rather than decrease. In terms of trying to just subjectively evaluate what was hurting their equipment, it seemed that there was a general consensus, somewhat supported by the research, that the mag chloride was the chemical that was really the most severely damaging to the equipment, particularly into the copper wiring. It really likes magnesium chloride, really likes to attack copper. And folks that ran a lot of mag chloride, and that's typically in the states, they're the areas that have the most severe temperatures because you're trying to clear that road at lower and lower temperatures, were the ones that really experienced that. Also with mag chloride, you saw a lot of the brake jacking going on, where you would have the brake pads separating from the brake shoes, and you would actually bind the drivetrain up of the vehicle. So this is a problem in the Rocky Mountain area as well as other areas. Some of the chemicals that were mentioned in the survey were, there was a product, I think maybe a regional product called a ice slicer, was one of the chemicals that a lot of folks out there used, and so on, and as well as just the regular brine. As I've already sort of covered the results of this here, it was interesting to know that 10 of the fleets indicated that they had done something, a variety of changes to try to mitigate their corrosion damages. At least 4 of them indicated that there was, at least 50% workforce compliance with their changes, and 4 of them indicated that at least one of the things they had done did not work. That's the nature of trying to deal with these things. Is in a laboratory you can control for a single variable, but out there in the operating environment there's an infinite number of variables, and sometimes you change something and it helps, and sometimes it don't, and it's really hard in that kind of environment to understand what worked and what didn't. So sometimes you just have to try different changes as well as just operator changes and training changes. There was some of the more important changes that came along was post-storm washing. This is another case where I saw a really nice video from MnDOT, put a plug in for those guys on the importance of post-event washing and what you should do with that washing. This was something that a number of the fleets noted that they had implemented post-storm washing practices with increasing and variable amounts of success. A lot of them were using neutralizing chemicals with soaps or other coatings. And maybe most importantly, and this is an area where you folks, a lot of those 2 areas, the post-event washing, the use of neutralizing chemicals, in lots of cases, this is your operators and your maintenance forces, and the folks in this room have varying degrees of influence over those practices. But in terms of this increasing your PM frequency, that was a practice that you folks certainly had the ability to bring to bear, and that was something that a lot of fleets said that when they were that after those storms they tried to get the trucks in for PM so they could at least have one opportunity or one shot at trying to address some of these issues, rather than having to rely on the maintenance forces to do it and just hope for the best until you get the truck back in. Only 3 of the fleets indicated that they'd ever been able to implement any widespread number of undercarriage washing racks, but that certainly was something that a lot of fleets indicated the desire to do so. But as we've heard, there is a significant cost with implementing those things, and quite frankly, in a lot of areas, the environmental regulations with trying to settle out the materials you're washing off the trucks and so on and so forth, those are all problems. But again, you look at in the case of Utah, at that time is a $225,000 fielded Class 8 truck. How many of those things can you rust out before you could buy a wash rack? Well, the answer is not too many. So, that we still feel like there's some real merit to trying to put those wash rack systems in, but we recognize that it's a struggle for you guys when you're facing a lot of competing desire for funds. A lot of the fleets did report that they were washing with fire hoses or pressure washers and so on and so forth. And one of my slides a little later here, we'll be talking about that. There's some extra research that suggests that using pressure washers and so on and so forth may not be the optimal approach, that it can push some of that chemicals up into hard to reach areas of the vehicle and really frankly make matters worse instead of better in certain cases. So we'll touch on that a little more. Of the positive changes noted from the survey, and as I indicated, some of the other resources we'll touch on later, use of stainless steel bodies. And every time I say that I have to grin, because down south they aren't bodies, those are beds. But there's a lot of the DOTs have switched to stainless steel bodies. That does seem to have had, generally speaking, a positive impact. Of course, especially now that there's a big tariff on the stainless steel, it creates some economic challenges to trying to do that. But in any event, it seems like there's a pretty good, fairly large number of fleets do feel like that has been a very effective practice to move to stainless steel bodies. They've changed the wirings, especially to try to reduce the number of junctions that are in exposed areas. There's a lot more trying to make end runs back to inside the cabin to protected areas, and those are all kinds of practices that typically have to be done through the specification development of your new vehicles and so on and so forth. The movement to a single rail frame design, which UDOT did and a lot of other fleets have adopted, seems to have addressed a lot of those issues. Still recognize that's not universal across the place, and quite honestly, one of the things you have to weigh these changes against is your secondary market, your resale market. I know in Utah we found that the secondary market for Class 8 dump trucks was pretty weak to begin with, and frankly the mining industry, the trucks were too heavy already to really be attractive to the mining industry, and they preferred the multi-rail frame design. So it's like a lot of things in life, it's about trying to, on one hand trying to spec a vehicle out to be the most efficient it can at the task at hand, recognizing that there's a secondary market for that vehicle. The more you try to go away from the norm, the less value it has in the secondary market. But that's part of the whole life cycle cost analysis that you folks as fleet managers have to deal with, is to try to balance all these multiple factors. Some of the changes that didn't work, and this was an interesting comment that Bruce at Oregon indicated that, yeah, the stainless steel bodies didn't rust, but it seemed like that it just made the rust worse everywhere else. And then one of the other changes that they were noted that were not effective, that Colorado and Idaho both indicated that they found powder coating to be ineffective in this thing. Idaho also tried using some special paint, which I think was probably an epoxy form of paint with limited success. And in some of these cases, that it wasn't that the practices were unsuccessful, they were simply deemed that the cost didn't provide enough benefit to warrant doing it. And that was, that's a difference between something that actually had some positive effect, but it simply wasn't cost efficient compared to what the outcome was. As I indicated, the Utah project, and again, this was also backed up by other research, the frame corrosion was typically linked to the gaps in the frames. The research that I mentioned by Western States Transportation Institute really emphasized the need to try to avoid having gaps between metals to where water could accumulate and so on and so forth. So there was getting rid of those gaps really helped. There was a general recommendation to try to move away from ferrous or rusting materials in those areas like oil pans and differential covers to non-rusting or rust-resistant materials. That could either mean, in some cases, we're talking about stainless steel oil pans or differential covers. In other cases, it could actually be composite materials, not even made out of, Kevlar or other types of plastics that are non-corrosive. And I've heard several folks over not just this conference, but the last couple of conferences I've been to, talking about changing in your electrical connectors to different types of watertight connectors and other connectors to keep this water out of your connection system off with. These are just common sense practices, but especially the longer you hold your equipment, the more important it is that you try to pay attention to these details, because time and exposure will show every little weakness in the system will show up at some point in time. Probably the most the most important thing, at least for Utah, in terms of trying to get additional funding, was to really identify, quantify, and communicate the impact of this corrosion on their fleet, in terms of trying to help justify replacing this equipment at the intervals that they were recommended, rather than continuing to be drug out and they're having their equipment funding not be adequate to meet their needs. And this was something, as I said, that time allowing, I hope to touch on a little bit how they were able to do that. Unresolved issues at Utah were, again, They still lack a lot of wash bays or commercial washing facilities. Utah's a pretty rural state, a lot of isolated areas, and they're just simply not easy to try to address some of those issues there. It is a area of some pretty tough weather. I was out there July 4th with my wife and got in a hailstorm that hailed 3 inches out on the highway on July 4th. So it's, and the combination of thawing and snow ice thawing and chemicals equals corrosion. So if you can't get those chemicals off your vehicle between snow events, you're going to have it. There's just hardly any way to avoid that. This next line item you folks can probably all appreciate, and that is that there's a real reluctance, and no one can really blame it. Nobody wants to try to get their folks out there in sub-zero weather trying to clean equipment or otherwise. So, you got to trade off, fight your battles, and sometimes I'm afraid the maintenance on the equipment or the washing on the equipment is what hits the bottom priority in that case. At this point, it sort of segue a little bit to compare some of the observations and experiences from UDOT to Illinois and Missouri DOTs. The projects, I did a project in the state of Illinois and in the state of Missouri. The subject of those projects was not corrosion prevention, in fact, the MoDOT project was a life cycle costing project, funding project. Illinois was a performance audit of the state fleet function. Having said that, it was very interesting that these projects came right after the UDOT project, and I saw a lot of the same equipment that was in Utah, in Illinois, and Missouri. These are both big snow states. The terrain's obviously not quite different, the altitude's quite different, but the snow volumes are very comparable. And the impact of corrosion on equipment was different. So this was interesting. Same brand, same make, same general specs, but different impacts. So, what was different? Well, as I said, 1,000 potential variables. So all you can really do is speculate a little bit. But I think the most important one is the first one here under the differences. UDOT, and Jeff can clarify exactly what the number is, but UDOT's the only DOT I've ever been in that is precluded by, I don't know whether you call it law, regulation, or otherwise, but they can't do summer maintenance. They basically can't do a job. Is it $250,000 or $300,000? It's a pretty low level. They can't do any project that exceeds $250,000 to $300,000 self-performing. So that effectively means the UDOT plow trucks set all summer long. They do not roll. So they are a special purpose, snow plow only fighting fleet, and they don't get used in the summer. And honestly, I think I'm speculating that the fact that they don't get used in the summer means they don't get a lot of attention in the summer, which means that there's a lot of these things that just set for months from the last time they did plow snow until they get some attention. So, that was interesting that actually UDOT's fleet, even though we recommended that they reduce their fleet age, was still younger at the time of this study than Illinois or Missouri's fleet. But their vehicles were in better condition. So that's the reason I'm talking about some of these variables that really make your jobs challenging is why, what works in one state may or may not work in your state, and the reason is not always obvious. So that's why it's incumbent on you folks to take the information you can learn and try to apply it to your own situation and make your own judgments. You can, learn what you can, but realize that not everything you learn is directly applicable. That's where you have to have your fleet manager's hat on and make your own decisions. I did notice that it was pretty interesting that in the case of Illinois, the trucks were pretty much and this is a North Carolina expression, pole barns. They were in open sheds that they had a roof over them, and they had either one back or no back. So a lot of that equipment was pretty much just exposed to the elements except for overhead, and the only thing I could figure out why their trucks weren't in a lot worse shape than they were was they must either had a pretty good washing policy, or they weren't in a heated environment between snow events to where they were going through freeze-thaw cycles. because in a lot of the DOTs, they'll throw the trucks into sheds between snow events, they get warm, the ice starts melting, the chemicals start working on them. In the case of Illinois, I saw no sign of that. And you know, the reality is I saw 14 and 15-year-old trucks with relatively little corrosion in a snow belt state next to the Great Lakes with big snow. And it's just pretty fascinating to see that. As I indicated, the Illinois project, I went to 4 of their maintenance yards. I've already talked about the conditions of the fleet, the age, etc. They were that, a lot of them had the nested frame design, but I simply didn't see a lot of that damage. In MoDOT's case at Missouri, I had a much smaller sample, really just looking at some of the auction yard cases and so on and so forth. And it was interesting to hear Missouri actually adjoins Illinois at the tip. And their corrosion seemed to be worse than Illinois, and I have no reason or no explanation why similar trucks in adjacent states would have different impacts. That's just, you know, there's, I don't know, Amy may have some more insights into that, but it was just pointing out the challenge that you guys face to try to address your local conditions. And, you know, it's just one of any number of variables that could be in play. And I think I've already sort of summarized this slide here, that it's just it shows you that when you're dealing with corrosion or anything in fleet, there's just no one-size-fits-all solution to it. You really have to look at your situation and try to interpret the information as best you can, what lessons you can apply and what things you should try to do. The real world is not a laboratory. There's just infinite number of variables. And I think the most reliable information you tend to get which is the one that it's maybe we're as a group probably more reluctant to accept, is the actual laboratory results where you're controlling for multiple variables and you're sort of focusing on that. Some of those laboratory experiences give you probably the most reliable guidance you can have in some of these areas where the questions really are very questionable. And when I'm talking, I think the work I referred to by Dr. Shee at the Transportation Institute, he did a lot of work in this corrosion area, and I know that there's several of you probably have heard him before. I really have a high confidence in the fellow. He's the Dr. Corrosion as far as I'm concerned. I want to touch here on a couple of slides quickly on the Washima's tour, scan tour. A number of the folks in the room right here were on that tour from Washima. A number of the folks in this room were actually generous enough to host those tours. I know that we had Minnesota, Michigan, Ohio, and Pennsylvania hosted. That's a very good report on that document, lots of good interesting observations. Some of them I think if you go to that report of their presentation, you'll find links to a whole bunch of those support documents of items that came up from that tour related to specifications, related to snow fighting, and so on and so forth. So if you haven't, please make sure you go to the Washima website or go to the EMTSP website, look for this Washima scan tour, and you'll find a whole website of links to documents that I think are good information, and I encourage you to look to. It's too much to try to cover here, and a lot of it started out, as I understand, as looking at corrosion was the sort of the thrust of the scan, but I think it turned out after everything's said and done that there was as much learned about differences in training and management practices and so on. It certainly wasn't limited to corrosion. The importance to me from the Washima scan tour was that the findings from that tour were generally consistent with the results that I indicated from the UDOT work. There was a shift, a number of the DOTs have shifted to the stainless steel chassis, or excuse me, the stainless steel beds and the single rail chassis. A lot of rerouting of electrical connections to reduce the number of junctions, to move the boxes inside the cab to where they're a little better protected, a general upgrading of connectors and so on and so forth. And there was a couple observations I just included in here because it seemed to be fairly consistent. A large shift to automatic transmissions across the DOTs. That was pretty marked from just a few years ago, that there's a much higher, and one of the more interesting reasons noted for that shift was that there's becoming so much stuff you're putting inside the cabs of these trucks for the operators that you're running out of desk space. You really are. The ability to have an automatic transmission that provides you more room for your GPS devices, for your AWS displays, and for all the other stuff that we're asking the drivers to look at. That was pretty interesting, that the use of automatics was a contributing factor to trying to address some of those other issues. So I mentioned there was a corrosion conference earlier this year in Sacramento. I know Greg and Doug, as well as Jim Chupas, remotely provided presentations at that thing. I've got a link here on this information, or on this slide that's in the deck. If you, after you go over, I would suggest that you might want to go to that website. There was more information we could possibly cover in this presentation, and I would encourage you to look at that. There was a presentation in particular that I found fascinating. I think a lot of the other folks there did as well, from the Marine Corps. Very interesting to hear what the Marine Corps was doing. I mean, they'd mostly deal with corrosive saltwater environments rather than snow chemicals, but their basic approach in a nutshell was all about don't let it get ahead of you. That every time you get a scratch on a piece of equipment, you grind it down, you prime it, you paint it. If you can keep it painted, if you can keep it from bare metal from showing, that's the plan, is don't let it get ahead of you. So I'm actually, I think Lisa had indicated we're trying to see if we can get this gentleman to speak at TRB. I think all of us were very impressed at his presentation. And again, if you go to the link, you can see some of the information there. It might be of interest to you. I think I've covered a lot of this material already in the slide deck, and there's too many things from here to try to just read through. But in a nutshell, there are some general themes. Just like we talk about preventive maintenance being the heart of fleet management, same thing with corrosion. Preventive maintenance, try to stay up with it. Don't let it get ahead of you. Keep your vehicles washed. Honestly, if you can't wash your vehicles between snow events and it's cold, just leave them outside in the cold and plug them up, because it's that freeze-thaw event that's really is killing you on a lot of these things. I won't read any of the other stuff. I will point out that very last bullet on this slide, and I know a lot of you have commented you are doing it. If you're going to have different types of metals bolted together on a vehicle, you better have something to isolate them, because they get that galvanic action going on, and all of a sudden you got a source of corrosion. So you know, the fleets, I think Doug at UDOT, and I think even MnDOT had talked about making sure they've got an isolating material between the dissimilar metals. These are just little basic things that over time just is the difference between, you know, having that corrosion getting a head start, especially in an area where it's just a big deal to try to address in retrospect. So this is important to spec and to try to address these things when you're getting ready to field a piece of equipment. I've got a couple of slides here. I would like to take a minute or two to talk a little bit about UDOT's condition assessment program, and I may call on Jeff here to try to update us a little bit. But this was the UDOT condition assessment program, they call it CAP, was a result of the work from 2015. In essence, UDOT changed their equipment replacement criteria for their Class 8 trucks from a 2-factor system of age and miles to a 3-factor system of age, miles, and corrosion condition. And Jeff can certainly provide you the current state of the program, but in a nutshell, UDOT already had a requirement that was a little bit unique, that they lay hands on every piece of capital asset equipment they had each year. So they had to go out in the field and put hands on every piece of equipment they had as part of their regulatory environment they were working in. So we used the fact that they had to do that anyway to piggyback that effort with taking Class 8 equipment, their big plow trucks, and once they were at a certain point of age where it sort of made sense to invest that additional effort to assess the condition of that equipment. We brought in the UDOT field fleet management team to develop this questionnaire. We ended up with, I think we started with something close to 40 things they were looking at, and we, through an iterative process, with a target of not less than or not more than 1 hour, and we really got it down to 45 minutes, that you could do an assessment on a piece of equipment in a reasonable amount of time to try to determine where corrosion was. And unless things have changed, they decided that it wasn't worth looking at their Class 8's less than 6 years old. Is that any different now, Jeff, or is it still 6? So starting at 6 years old, they go out there and they look at 21 areas. Is that still 21 areas of the equipment, and they assign grades, letter grades of A to F to each of those 21 areas. In the model that they developed to support this scoring, they have weighting for each of those areas, and they have cost associated with each of those areas. That the idea is that if you have an area that is below a C, which is an average, that you're going to have to spend some money to try to keep that truck from getting into serious trouble. So the idea was, how much would we have to spend to bring this component on this truck that's currently at a D, which is below average and needs work to, or an F, which is basically it's in a failure mode, it's unacceptable, you got to do something about it, bring it back to at least a C. Now keep in mind, this whole condition report assumed that age and mileage was taking care of the wear and tear. So this was simply focused on corrosion. The outcome of this thing was that UDOT developed a model, and I think that UDOT, this was something they developed internally. It was based on a model design that the consultants provided, but in essence they produced a in-house program that's web-based, that they can load these forms, beat into the system, it loads into an Oracle database, and it produces a report on the score on each piece of equipment, gets a score, and that score is in a hierarchy within the fleet. And they can come up with an estimate of the amount of corrosion damage they have on each piece of equipment, and as part of their equipment replacement program, their report to the legislature with their budget request, they're able to document what the impact of corrosion is on that fleet. And if they don't get the funding to replace those vehicles, they're going to have to spend to try to mitigate that corrosion. And in the next couple slides, I'll just show you a couple of those, what those sort of the report outcome looked like. Now this is the inspection form. Obviously you can't read it from your distance. You can see it's just a one-page form. And you just go through it and you put a grade. And then in the case of UDOT's case, they got a core group of traveling mechanics that go around the state, so there's not an issue of training and variability, because you've got a small group that's doing all these assessments, so it's the same people that's assessing all the vehicles. It is important to note that they tried doing this decentralized, and they ended up with so many people scoring on so many different ways that, and not to mention trying to game the system, that this was the only way they could really make this thing work, was having the same group do all the scoring. And I think it's, as I indicated here, it's certainly been a success for them. The slides, the next couple of slides I have are from 2016 numbers. This was from a presentation that Jeff provided at Washima last fall. Jeff indicates he does have the numbers now for 17 and 18. I just didn't have them at the time I put this deck together, but for those of you who are interested in those things, I'm sure Jeff would be happy to share some of that information with you. But as you can see here, this is for the Class 8 fleet in Utah in 2016. He had, you see the pie slices here, how the distribution went. They had 31 units rated with an A, 43 with an F, 88 with a D, 102 with a C, and 94 with a B. So they had the distribution, obviously relatively few A's, not a whole lot of F's. Most of the distribution was between the B and the D category. Importantly, you were able to compare these scores region over region. The idea here, this is all about, now we're into performance reporting. Now all of a sudden the regions or districts, or it's regions in Utah, the regions are measuring themselves against each other. What happens when people get measured and that information gets communicated? They become competitive. Nobody wants to be on the bad list, end of this list. So all of a sudden you're creating incentives for your people to take better care of this equipment because they see it's something that's reported not only within UDOT but to the legislature. This is part of their equipment repair support. So you can see the grades by region. I won't dwell on that. It's too small. If you go to, if you download the presentation later, you can look at these details. But the point is, all this, here's another one, costs by region, projected costs. And again, this is all about showing you where you are, where you think you're going to be, with the idea that you're going to encourage people to do better, and you're obviously having a objective way to try to figure out and show what's going on with your fleet. You're telling a story, and I think that's one of the most important things that a fleet manager does, is to be able to tell their story. That's so important. I know Scott tomorrow will be talking about the performance measures, and this is simply, again, this is another one of those indecipherable slides from your distance, but the net of which is that this database that UDOT built for this purpose tells them where the problem is, what's causing most of their problems, what's causing those grades to be down in a particular area. And importantly, the whole application was designed so that if UDOT wants to change those weightings or change any of those factors, the tool will allow them to retain the current values and reanalyze the past values to see what, if they had had this weighting 2 years ago, how it would have changed our numbers. So I think it was really a very nice application they developed, and you know, I certainly am trying to guess. I want to make sure that Jeff's a pretty modest guy, but I think they did some really fine work there, and I just wanted to make sure that you folks were aware of it. And I dare say that Utah would be more than happy to try to share this stuff with you, since it was a state-developed resource. And I do think there's something for those of you who feel that trying to have some kind of condition assessment program, being able to effectively report on that program is where the real payback is on this stuff, is to try to communicate your message. So in summary, the UDOT used this report and used this program to identify the potential cost of repairs. It helped them create a better awareness of what future problems were out there, allowed them to be able to trend how they were going, whether they were getting better, whether they were getting worse, and paint a nice picture of the overall fleet health. I don't think there's a fleet in here that I've heard, the closest I think Stanton, Alabama is probably the only one that's not, seems to be fighting this losing battle against having greater needs than you have funding. But you know, your ability to get funding is a large extent of just how well can you communicate that need and convince your bosses and the powers that be to fund that need. So again, I think, and Jeff, I'd ask you here in a second, is I understand that UDOT was able to get a 50% increase the first year after they put this program in, and I think now you're pushing another close to 50%, Jeff, or something close similar?
Our normal replacement budget was $6 million, and through reporting this, we've actually been able to double it. So now we got $12 million to spend on replacement.
And I think your hope is you're going back to the drawing board and trying to get a little more mileage out of this. But
yes, and it works so well that our loader fleet is falling apart. So now we're going to adapt that program over to our loaders to start reporting on those as well.
Any questions or comments while I'm up here? Well, thank you for your time and attention.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.